Now we will put the channel to plus minus 10, channel B to plus minus 10, trigger to auto, external, falling edge, and this is, we'll set it to 2 volts. Okay, this will ensure that the screen does not keep changing. It is triggered to an external trigger. Okay, so it will be fixed now. All right, so let us first start with looking at our line encoder output, which is connected to channel A1, all right, and our modulator output, which is connected to channel B. All right, let us zoom in a little bit so that I can see the phase changes a little bit more. All right, if you see here, when it's a 0, it is starting from 180. When it's a 1, it should start from 0, correct? We will use our phase shifter that is connected to the modulator to make sure that I have a good M and a good W. Okay, just tweaking a little bit, you see that I have a good W and a good M, good W, and good M, right? Mm-hmm. All right, now let us look at the multiplier output. Okay, multiplier output, we take this out. This is my multiplier output at the demodulator, and we somehow get a pattern of what was transmitted. All right, let us check what happens to my low pass filter, like after the multiplier output goes through a low pass filter. As expected, I don't have a good pulse, okay, because it is distorted, right? If I check my output after the low pass filter with decision maker, I can see that the distorted pulses are somehow made to square pulses. Obviously I can play with the decision point, that means when to take the decision. If I make it smaller, so now the decision maker takes decision at this point. If I go a little bit more, that's it. If you go more, suppose you take the decision at this point, it will be confused. Okay, so this is good enough. All right, so this is the pulse that I transmitted and I received it. I will then pass it through to the line decoder. Okay, let me look at the output after the line decoder. So decision maker, so this goes away. This is connected here. Okay, so if you see here, because I'm using NRZL, so whenever it is 2, it is changed to, it was the other way around. So when I use NRZ over here, that means 1 was made to +1 or +2, a 0 was made to -2, so it was bipolar. Okay, so it is bipolar here. If you see here, it's bipolar, and the line decoder only changes it back to its original form, right? So there are like 1 0 0 0 0 0 1 0, something like that transmitted. Okay, let us check if this is what was transmitted by the sequence generator. So I'm going to compare it with the sequence generator. Okay, and if you look at it, it's, let me bring the sequence generator output down. Okay, so the red is my output and the blue is my input. Obviously the red is little bit delayed. Okay, and the good thing is that the delay is constant everywhere. Let me zoom out a little bit. So you see that 1 1 0 0 0 0 1 1 0 0. So it's just delayed a little bit. Okay, so I get the message but little bit delayed. So it's fine because there is so much of delay that is there. As long as the delay is constant, it's fine. All right. So we have successfully transmitted bits and received it using BPSK. Okay, we will see the effect of the phase shifter that is used in the receiver, because the phase shifter is to ensure that the phase difference between the carrier that is used in the modulator, demodulator and modulator are same. If there is a phase difference, if you look at the output,
So it remove the delay.
it will not remove the delay, it will just change. It was 0 was transmitted, but you received 1, so it totally reversed your message. Okay, so you just have to fix it, just play with the phase shifter so that you get what you transmitted. Okay, all right, that's all. Thank you. Okay.